Hello friends, welcome back. Today I am going to teach you a very most important concept from topic binomial theorem, and this is required for 11th standard student. Or anybody can use this Pascals triangle to solve their problems based on the identities. As you know, what is meant by identities, why they are called identities, what is their use, everything. If not, then watch my earlier videos based on that concepts. So without wasting time, so Pascal triangle. So here on the screen you will be seeing different hexagons, and every hexagon I have written one of the number. So what the numbers are, how these numbers are formed, that I will tell you step by step. So these are the hexagons, and this figure is in the form of triangle, and this was invented by Pascal, a mathematician, and that's why it is called Pascal's triangle. Now, so this is the triangle, and in this triangle, property number 1, any number, suppose this 10 number is the sum of two numbers exactly above it. So this number 1 is the sum of two numbers exactly above this number and this number, but here no number is there, so it's consider, if there is nothing, consider it as 0. So 1 plus 0, 1. So here 3, this 3 is sum of two numbers above it. Above it there are two numbers, one is 2, another is 1, so 3. So this way this triangle we need to complete, and we are starting writing the triangle, elements of triangle from this 1. First write 1, then next property. So see, this corner element, that is we can say starting numbers or corner numbers, and these are the ending numbers or end corner numbers. So these are always 1. These are always 1. Now, in Pascal's triangle, these are horizontals are rows, and always start with row 0. Never start with row 1. Call first row is row 1, row 0. This second row is row 2. This is third row, but row 2, because we are starting from row 0. Row 0, row 1, row 2, row 3, row 4, row 5, row 6, row 7. Then see these rows, second rows. So sometimes this is also first row, second row, third row, 5th, 6th, 7th, 8th, and so on. So these rows, second rows. These rows are natural numbers. 1, 2, 3, 4, 5, 6, up to infinity. It will goes on. Row 8, row 9, up to row infinity. Then this first row, second row, third row. Yeah, first row, second row, third row. This row, third row. 1, 3, 6, 10, 15, 20, and so on. So these are the triangular numbers, or these numbers are 1, 3, 6, 10, 11, 15, 21. These are the triangular numbers. If we arrange these numbers in a dot pattern, it will form equilateral triangle. Equilateral triangle. See, 1, 3, 6, 10, 15, 21. Dot pattern, triangular numbers, equilateral triangles. In the class 6 we have learned this concept, correct? Then next property. So sum of elements present in the row. So if we do the sum of row 0, that is 1, row 1 is 1 plus 1 2, row 3, row 2, 1 plus 2 plus 1, 1 plus 2 plus 1, 4, row 3, 1 plus 3 plus 3 plus 1, 1 plus 3 plus 3 plus 1, 8, row 4, 1 plus 4 plus 6 plus 4 plus 1, 1 plus 4 plus 6 plus 4 plus 1, 16. So how this pattern shows? What this pattern exactly shows? This pattern shows 4 we can write 2 raised to 2, 8 we can write 2 raised to 3, 16 we can write 2 raised to 4, and so on. And in general we can make statement sum of each row, sum of elements of each row is equal to 2 raised to number of rows. So this is second row. So 2 raised to 2, 2 raised to 2, 2 raised to number of rows. This is third row, 2 raised to 3, 2 raised to 3. This is fourth row, 2 raised to 4. Now you can check this for seventh row. 1 plus 7 plus 21 plus 35 plus 35 plus 21 plus 7 plus 1. 128, which is equal to 2 raised to 7. 2 raised to 7. Seventh row, 7. Now another property, and this is most important property. So you know a plus b raised to 2, a plus b square. This is the identity, correct? And its expansion is a square plus 2ab plus b square. This 2 is called power of terms or index. This is called index or power. And this triangle gives us binomial coefficients. Binomial coefficients means coefficient of this, coefficient of this, coefficient of this term. 1, 2, 3. These are the different terms. These are called terms. And every term has coefficient. If here is 2 is coefficient and a and b are the variables. So in term there are two things, two terms, two subterms. We can say one is coefficient, which is constant, and another will be variable. Variable whose value is varies. Whose value varies. If here is nothing, is like we can't see any coefficient here. But if there is nothing, there will be a 1. Always coefficient 1. So these coefficients are called binomial coefficients. So see here, index or power is 2, coefficients are 1, 2, 1, and see Pascal triangle. Row 1, 2, 1 are the elements of Pascal's triangle of row 2. Row 2 means here this power is 2. If binomial has power 2, their coefficients are given in row 2 of Pascal's triangle. Now a plus b bracket cube, 1a cube plus 3a square b plus 3ab square plus 1b cube. Coefficients 1, 3, 3, 1. C 1, 3, 3, 1 from Pascal's triangle row 3. Row 3 means power. Power of this binomial becomes row, and the elements are the coefficients of different terms from this binomial. Binomial means to binomial, two terms, 1 plus 2 terms. Now these are the some historical things. So this Pascal's triangle is also called as stair of Mount Meru. It is also called as stair of Mount Meru. In Iran, it is called as Khayyam triangle. In Iran, it is called as Khayyam triangle. In China, it is called Yang-Hui's triangle. In China, this triangle is called Yang-Hui's triangle. And in India, you can call it as Pascal's triangle. Blaise Pascal. This was the mathematician who discovered or who invented this triangle. And like this, 1, 1, 1. This 1, 1. This is sum of these two. Here, sum of these two. Here, this element, sum of these two. 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 And go on, continue. And this was the 0th row. First row, second row, third row, fifth row. And all other properties I have explained earlier. In the next video, we will solve some numericals based on this Pascal's triangle. If you like the video, please do share it and subscribe channel for more such fruitful videos. You can call me for home tuition also as well as group tuition also.